if you're going to do that route, anywhere between $50 to $200. But the stuff on the airplane itself is pretty cheap.
Yeah. All right, so wonderful presentation from Nick. Up next we have Ken Purcell. Ken Purcell, are you here? Ken Purcell, come on down. And on deck we have Dwight Barnell.
That little one, I'm probably doing 50, 60 miles an hour. I've got some people with ones more of this size, getting like 90 miles an hour. There's some RC airplanes I've seen that are doing 150, 200 miles an hour. It's insane.
Probably not going to
Yeah.
This?
I'll have to demo this outside.
Yeah.
Because we'll take out the wire.
That'll make people want to stick around though.
Oh, yeah. Okay. You ready?
Yep, go for it.
Okay, most of you have probably seen this at the Science Place back before they moved to the Pro. The Pro still has one, but they have a tiny one. This one I built for them, but the person I built it for has since left and never heard from her again. So anyway, so this is a Van de Graaff generator, VAN space DE space GRAAFF. It's very hard, so if you're searching for it on Google, you'll need to spell it that way. This is a high voltage device. This is what they used to use to actually drive some of the first particle accelerators. You want me to move it where you can see it? On camera? Okay. This is a device that actually they used to use to generate static electricity as opposed to your wall power or battery power and all that. It's actually a mechanical device. It's not electronic anyway. The only reason it has a motor is so you don't have to crank it. So you can spin it up pretty fast. It is essentially composed of two rollers that are what are called two elements on the triboelectric series. And essentially they're things if you rub, you can either rub electrons off or they collect electrons. And they're two different ends of that spectrum. One actually gives electrons, one takes them. And this is just a latex belt that through friction collects electrons from the bottom, transports them up, comes on this grid. This grid, these are not actually even touching this, they actually just jump across this little gap. And then they collect on the big sphere. The reason why you want to collect them on a big sphere is essentially this is the one side of a capacitor. And so you store the electrons on the entire surface, and so that's how you get high breakout voltages. And you can then power other things. This one will produce 600,000 volts, so that's enough to make a 28-inch spark on a dry day. Humid days, not so much. Basically, it depends on how dry the air is. So if you put this on here, it'll actually collect that, just touches the top, and then the electrons will fill the space. You've probably seen them in demos, and we'll do this later. We could do it probably room 1 or outside. So you can actually stand on an insulated box, and you then can collect electrons. And then your hair stands up and all those kind of things. So it's a pretty simple device. Not too many of them ever get built this big. Most of the times you see them, they're little tiny things, but the little tiny one this tall will be about 200,000 volts. And the harder part to actually get this to the performance of it is actually getting a high current. Normally, to get little sparks, it doesn't take a lot of current, but you can make a lot of voltage. This one produces 50 microamps, which is actually high for a Van de Graaff generator. They do make them 8, 10 feet tall. You can actually polarize these to one would be positive and one would be negative, and then you get double the distance. This one will put out 28 inches on a good day. What else? As you can see, most of it is made out of acrylic and cut on the laser. This is just an acrylic tube. Actually, I had to replace this with another plastic. I can't remember the name of it because acrylic cracks too easy, especially when you put high voltage on it. Any drill holes you put in end up making it crack. Let's see, and that's pretty much it. It's just a fun little demonstration piece for science. Probably actually have to send it out to the science lab at some point. Let them just keep it. Any questions? Anybody want to build one? We can make a second. I have enough parts to make a second one. So. The hardest part is to get the gazing sphere, which you get for AliExpress, and this part is very dangerous to cut.
How did you do it?
With a cutoff wheel very carefully. I actually made a jig. I held the cutoff wheel and I had some spokes and I actually just turned it against it.
Nice.
So.
Where did you get the base from? I mean,
This AliExpress. They're only like $20, but the shipping was like $40. You can get smaller ones at Home Depot. They sell like 12-inch ones. It's called a gazing sphere. So they have them out from the garden center. For a garden center. There's a bent aluminum, brass screen, other basic hardware from hardware section of the hardware store. So. And this is just window trim, and that's just to keep this on here. Actually, we do get a lot of corona linkage down off the bottom because this is kind of a sharp edge, and we'll get strikes all the way from the top down the column to the bottom. So.
Is it dangerous?
Well, I can't run it in here because the Wi-Fi. It'll actually disrupt radio communications of all types. So hammer operators hate it.
Getting electrocuted or burned.
If you have a pacemaker, you probably wouldn't want to be around it.
Okay.
But it won't really hurt you. Yeah, you can actually get burned if you just want to sit. But your normal reaction is to jump away. So really, after the first one, you'll jump. We would run it out there, and it would charge up anything that's metal. The electrons will spew off of here and collect on those surfaces. And if they're insulated surfaces, you'll walk to other things, and they'll shock you too. So like when we ran it before, we actually charged the grid of the ceiling because it's not grounded. But we have enough to build a second one, so I'll try making a second one, and I'll make one positive, one negative, and we can get 38-inch sparks, 40-inch sparks. Pretty cool. Okay. We'll run it outside later.
I predict mayhem later.
Could you build a sphere out of aluminized mylar?
You can make your top sphere out of anything.
Yeah.
The issue with it is you want it really smooth, otherwise electrons will take any irregularity and jump off that point. So this has to be really, really smooth to collect it, and that's how you actually get high voltage breakouts or current. Otherwise it'll just be a low current machine. So. Very cool.
Does it have an amp? It should have an amp. It's not sparky.
Not sparky. That's actually pretty good. Yeah.
Especially if you have two.
I mean, it's got to be like a Dutch name, right?
Yeah,
it's a
yeah,
Van de Graaff generator. Is that Dutch? Van de Graaff?
That's
Is it
pretty
a
cool.
Dutch? All right, so thank you so much to Ken for showing us this Van de Graaff generator. Up next is Dwight Barnell, and I'm gonna mix it up because variety is fun. So I'm gonna go out of order a little bit. So Ebony Jackson is on deck. Right here. Put that to you.
Key this up here.
We could have this guy at
I was so back out. Yeah.
Is this mouse with that? Yes.
Hit the 3 yellow lines to the right. That one, and then see where it says 100%, just to the right of 100%. Down, right, just to the right of that. That, one more to the right, one more to the right.
Oh,
Right there, yeah. Yeah, F11, you're right, much easier.
Good evening. My name is Dwight Barnell. I'm president of a company called Wheatcraft.com. We manufacture ground effect vehicles and sell them around the world. I want to thank Ebony for inviting me here tonight. We were at a Kickstarter meeting in the Dallas node, and told me all about what you guys were up to. And then Jay gave me a nice tour of your facility. Jay or Jake?
Jay.
Jay. You've already given me a bunch of ideas as far as R&D, a ton of R&D that we're have coming up really quick. After I heard about this great place from Ebony, it occurred to me that I could come talk to you guys about our newest project, which is the Drone Corporation. Drone Corporation is basically made up of several entities, NAFTAR being the main one. It's the National Association for Drone Aerial Racing. We looked at drones, I've been involved with drones for about a year now in the training environment. NAFTAR came as a result of us looking out in the marketplace to see what was going on in the drone world. So we looked at, we've already had some practice with the military with some of our drone training, and then we looked at some of the drones that are being used for agriculture. But we were looking for a business model that had legs to it and that could really grow into something really quite unique. So we thought about what NASCAR represents and what they do as a racing sport industry, And then over the summer, a lot of racing came about in the drone world. And so we looked at it a step further and looked at the idea of, well, listen, we can race aerial drones, we can race airplanes drones, we can race car drones. So we looked at it in a huge picture in terms of creating a nationwide national organization. So we came up with NAVTAR. So NAVTAR is our branded name now that we'll be pushing and launching in the months to come. We also came up with the new term electric drone racing vehicles. So that'll be an acronym that we hope to push out there. And then in order to put drones, racing drones to the masses, we have to create something where we can distribute those drones. And it's always nice when you can physically visit with somebody and they can tell you about the industry and all the things that you can do with racing drones and just the wonderful nature of that sport. So we came up with the idea that we needed a store. Not so much a brick and mortar store, it costs lots of money, but more of a kiosk style store that we can put out in the malls. So you can physically go to a mall, look at a racing drone, assemble one, piece one together, and buy it on the spot. So we decided that this has to be open for everybody, and so that's why we came up with the idea of putting out drone stores. So one of the aspects of this place was we need to design a kiosk that's effective, that we can put together, that will hold all the equipment and parts and pieces of the drones. And so that's one thing that we want to look at with your place here. I mean, it's just very, very interesting. Going down here, I want to show you guys. Part of the plan is to create cars that are drone operated. In other words, you could be in Hong Kong racing at Texas Motor Speedway. And so that's really the idea that we want to get across to the consumer and the operator, the pilots. Same thing with the aerial racing. Here's this doesn't quite. I think we're missing something. Auto and aerial drone racing will revolutionize sports. That's going to be our mantra. That's going to be our mission statement. This is the drone that we manufacture in Russia and in New Jersey. I'll let you see it. I'm going to show this for a minute. This is the drone that we sent to China. They loved it so much, they ordered another one.
So by drone, are you saying it's unmanned?
This one, these two are manned, but we are now building a drone version of this.
Like a small.
We have a contract to. It's similar to DARPA, but it's not DARPA. It's another organization that wants us to drone out an aircraft using the BD-12 design.
So what's the point of this form factor? I mean,
The point of what?
The form factor. So what makes it not a plane and not a...
Well, number one, it's not an airplane. It's a maritime vessel. So we can use diesel engines out of Mercedes trucks, for example. This particular airplane has two Mercedes engines, 550 diesel horsepower. And then our propellers are composite, for example. So we're not in these rules of all the FAA Part 121, Part 125 rules of manufacturing. We're in a different world. So.
What's its ceiling though? I mean,
ceiling is, we can actually go about 120 feet.
Okay.
But we want to stay in ground effect where we have the maximum benefit.
And
Ground
how high?
effect is the distance of your wing turned on its side.
Oh, that's okay.
Yeah, and very, very efficient. I mean, we're only burning 50 gallons an hour, and we can fly 1,000 miles. These particular versions, we can carry about 15 people. And we've since have 7 more orders with China, so we will sold a total of 10 aircraft, or 10 wigs, we call them, boats. But we're, like I said, we're developing this into a drone as well as we speak. But it's very effective in terms of its operating cost and compared to a real airplane and things like that. Anyway, I wanted to show this to you guys. You know, the DARPA or NAVTAR is based on automotive and flying and drones, and so that's really our concept, is to offer an activity where you can race, be virtually anywhere in the world and participate in a race somewhere. So we're jumping on board full swing. We want, I want to show you this aircraft. This is This is called the Sandstorm. It's produced by a company called Unmanned Systems in Las Vegas. And this aircraft was actually built for training the MQ-1 pilots at a low cost. So we're helping them right now develop this into a commercial business, a commercial drone rather than a military drone. So we're excited about that, some of the work we're doing with them. When you're at a race, or the nice thing is you can actually watch races from your home of an actual race that's going on, for example, like Texas Motor Speedway. You can switch from driver to driver to driver in first-person goggles. So you can actually see what they're seeing, for example. So that's really the idea, is to promote this as a new sport across the board with automotive and the quad drones and the airplane drones. But we're excited to find you guys, because there's just a lot of different things that we can R&D out of here. And this, by the way, this was the first or second Grand Prix all-electric race car race in Europe last summer. So it's people driving the vehicles, but my point is these small vehicles that we want to develop, all easily 200 miles an hour vehicles that you'll be able to first person operate as a drone car that you're participating in a race. And just like NASCAR has several different programs for young people starting at age of 8 or 10 to 12 years old, they're the same kind of thing. We want to make it available for the masses. Thank you. Yeah, thanks.
So grab that.
Oh.
All right, thank you so much to Dwight for that presentation. And up next we have Ebony Jackson, and I'm actually going to be on deck after that. Getting this into the TV?
I'm casting.
Oh, you're casting it, okay.
No.
We have picture.
Woohoo!
Perfect.
All right. My name's Ebony. Thanks for the shout out, Dwight. But I'm mostly involved in the science area, and I'm usually around the makerspace a lot. So. But I'm really here for recruiting purposes, children and teachers. I'm working with a group called MinecraftU.org, and our main goal is to get children more involved in programming at an early age with a more interactive environment. Right here, it's usually hosted within Dallas, and so right now we just do an on-site camp. We're going to eventually move out to a virtual camp where the teachers will log online with students and guide them on how to develop programs and the basics of Minecraft. So one of the things that you can learn within our organization is a couple of things. First, starting off with electricity, how to design circuits within Minecraft. Right here is a regular circuit. You see it's using redstones to power the circuit. Another thing we're trying to do is use command line. So we have a computer wiki mod within the Java or within the Minecraft. So students can learn how to build computers. Here's one, kind of old school. CD-ROMs, floppy disks. They can learn how to build computers within Minecraft and actually the logic that goes behind it. Using command line interface and other utilities. And another one is using developing a mod. So what a mod is basically adding on to the Minecraft world, and you're actually programming. Say if you want to program a world of your own, you can do that. So we teach kids to use Java-based programming to develop their own mods. So they can develop blocks, worlds, computers, anything you can think of. And so like our main goal is to get, like I said, kids involved. We also are recruiting teachers. So if you're not busy this summer and are willing to hang out with some fifth graders and all the way up to high school actually, so seniors. So I'm just gonna do.
Are fifth graders awesome?
For the most part, you know, when they eat, yeah. So basically, we usually host out a Hackaday. I believe it's about 3 weeks, starting in June 6th, all the way up to July. So yeah, for instance, middle schoolers, we give. So a couple of sessions. Sequence 3 is more of a basic intro to programming, and sequence 4 is basically where you learn how to develop mods and, you know, use Java programming and other professional skills that they won't be introduced to until they reach college. So our main thing is, even after you leave the camp, we would encourage students to keep up with Minecraft. I mean, it's kind of addicting in the first place, but the fact that they can build their own worlds by their own by using their own programs is the main idea we're trying to reach out to. So if you are interested, you can email me at jackebony92@gmail.com. As far as teachers goes, we take anybody. If you know how to program and you can drive yourself to the camp, that would be great. We do whitelist our servers, so we try to protect everybody that's on there, especially children, because that's the important thing. And tuition is about $375. Yeah, it's kind of a hassle, but we offer open curriculum, so you can actually go on our site and just, you know, do about 4 of the curriculums that we have available, and you can eventually teach yourself. We have an open source project on GitHub. If you're willing to contribute, that would be great. So we are looking for contributors, more to add to our curriculum. So yeah, so if you want to email me at jackebony92, that's EBONY92@gmail.com. And then also, if you just want to check out updates, you can visit minecraftu.org and click on the, type in your email address and click on subscribe, and we'll see updates about our camps. Thanks.
Great, thank you. All right, so thank you so much to Ebony Jackson for that presentation. I am up now, but right after me is going to be Larry Bentley. So Larry, if you're in the building, please get ready. I feel like I put that on the wrong way. Is this okay? No? All right. New computer, never tried it with HDMI before. Kind of like magic, except for go. View, present. Nothing?
Nice background there.
Thank you.
Cash recommended drone.
Do you see it now?
Yeah.
There you go.
Oh boy, I'm sure there's a better way to do this. Sorry, everyone.
That's why you should come to rehearsal.
Present. Oh, hey, and I'm at the very last slide. Oh my gosh. Oh my god. Okay. So, I have the wonderful job of working for Hackaday, and I get to go to different places, and I'm going to Belgrade, Serbia. How cool is that? So, here's the thing about Hackaday. We have a huge worldwide leadership. We went to a 24-hour publication. We published an article at least every 3 hours around the clock, because we had so many people reading in different countries. And like in 2014, we actually wrapped up the Hackaday Prize in Munich, Germany, and did like an all-day set of workshops there that were packed. And when it came time to put away the tables and do food and beer, like people wouldn't leave. They're like, I'm hacking. We had to like kick them out of the table stuff. So we're actually expanding that and doing a big conference in Belgrade on April 9th. And one of the really great things about Belgrade is one of our contributors at large, Voja Antonic, lives there, and he's an embedded developer, like going way back. He has his own Wikipedia page, which I don't know, I think that's kind of cool. And he back in the 80s was like the Steve Wozniak of Belgrade, which was, or of Serbia, which I don't think was Serbia back then. It might have been Yugoslavia.
Yeah.
And it was behind the Iron Curtain, and so a lot of the chips that you would use to make those computers were embargoed and that sort of thing, and so he kind of had to figure out how to do it with what was available to him. He's written some articles about this. It's really great. You should go look it up. Oh, I'm jumping right into the story. So I'm going to get right back to that. That's the hook. So I'll come back to that in a sec. This guy is actually sitting right over here. That's a picture of Brandon Dunson, who really like moved mountains to get everyone on board with doing this event today. So we just give a big round of applause for Brandon. And he has Mrs. Penny's Driving School is his teaching tutorial series on electronics, which you should sign up for here at DMS. I also wanted to thank DallasMakerSpace for opening their doors to us. This is not possible to do if you don't have a place to do it. And I'm not going around renting hotel ballrooms to do things in. Like, you need an awesome place with the community to have fun like this. So thank you so much to DMS. If you're not a member, consider joining. SupplyFrame, which we haven't said this name enough. SupplyFrame is Hackaday's parent company. And SupplyFrame does a lot of really awesome things like findchips.com, which is a vertical search for components. They have parts.io and quote.fx. And a few years ago when Hackaday went up for sale, they said, we really believe in the Hackaday community. We're gonna buy Hackaday and support it. And they're the ones that give us a budget to go around and do stuff like this. They're the ones that present the Hackaday Prize every year. This year it's $300,000 in prizes. And they promote open source initiatives and open hardware, and are really great people. So thank you so much to SupplyFrame for making it possible to be here. So back to my story about Voja Antonic. So he's like, you know what? I'm gonna make a hardware badge for the Hackaday Prize, for Hackaday Belgrade, this conference I'm going to that we're hosting on April 9th in Belgrade. And this is like the first I heard of it. He's like, hey, I made this prototype of a badge. What do you think? And this is not a render. Like, this is the actual badge. And then he sent me one, and I'm like, there it is. There's a badge right there. That's amazing. And so that's the guy right there. He's a wonderful man. This is the schematic for the badge. Does anybody know what schematic program this is? I've never seen this before. Anyway, so it's trivia. I'll give you a free beer in the other room if you get it. So at any rate, it's really an interesting story. He had this whole thing designed, and he built it around this PIC 18 25K50 because it has USB already built in. And he's like, if I make a conference badge, I want everyone at the conference to be able to reprogram it and hack on the programming and stuff. And if you have USB built in, then you don't need a programmer. You can just like push it to the badge. So then I have some friends that work at Microchip, like they're field applications engineers. So I'm like, hey man, look at this badge that this guy just gave. And then my friend at Microchip is like, where are you getting the processors from? And I'm like, I don't know. He's like, do you want us to donate them? I'm like, yeah. So they gave us like 300 of these processors, which is great for the bill of material. The conference, we're charging for the conference, but we're charging the cost of the badge for the conference. So that's really cool that they did that. These displays are 8x8 red LED displays, and they're common cathode, which means the low side is driven by this. This is just like a shift register right here. So only one of these columns is ever on at any given time. So this decides which of these rows. This decides which of the rows should be lit up. So if this column, if you just want to have these three lit up, it's just these three that have data on them. And then these are the high sides. These are P-channel MOSFETs, which switch the current on for whichever row. And you switch them so fast that your eye can't see that it's not happening. It's got a IR transceiver, built-in IR LED and IR receiver, so it's like the remote on your TV, so the badges can talk back and forth to each other. He built 3 buttons into it, but I mentioned I had, and there were some more designs. I said, well, 3 buttons, you can't do like a game of Snake, because you can't do like up, down, left, right. So, I mean, he wrote Tetris, which is good, but I wanted to write Snake. So then he's like, okay, and then I'm like, and it'd be nice to have a select button too, so you put a teeny little button right there. And then we kind of threw that out and said, that's not very good. So I sent these designs to my friend at Microchip, and he's like, oh man, there's all kinds of problems with this design. I remember this guy, Voja, like, was building computers, 30 years ago. So I'm like, how do I go to this guy and be like, well, my friend said that your design has some problems in it. So, and it wasn't just my friend, I got like 4 different engineers to look at it and kind of say the same thing. So he's like, oh, you have a diode set across your power rails, and if someone's going to put the battery in backwards, batteries don't have very high resistance, and you're just going to blow that. And Voya's like, no, actually it can stand 3 amps of current constant at a much higher peak, so that's not it. And then another guy said, you can't link together that, you can't put the latch and the clock signal together on a shift register. And then Voya's like, well, no, if you look at the data sheet, you'll find that the clock is edge triggered and the latch is level triggered. So you're not going to have any problems with that. And then someone else is like, well, the shift register is actually only rated down to 3.3 volts. And if you have 2 batteries, that starts at maybe like, what, 3.3 volts and then goes down from there. And Voya's like, no, look, I tested it. It works down to 1.6 volts, no problem. It won't actually start up again, like the oscillator, but it's fine. And if you calculate it, it's like, oh man, it's like 18 days of on time or something. And then they're like, oh, you know what? The USB bootloader, it's going to have voltage creep backwards into the batteries if you have the batteries run down a little and you have the USB be on the high side of the voltage. And the voltage is like, Voya's like, oh yeah, you're right. I have a protection resistor in there that should be a little bit more. So we changed 1 resistor. So this whole design got edited by a bunch of people and came out the other side like glowing, which is pretty cool. My part in it is I actually built a software emulator with it. So this is like the screen, and it uses keys on your keyboard so that you can write your own code for it. So what we're planning to do is have kind of like a demo scene contest where even if you're not at the conference, you can download this emulator, write your own code, send it to us, and then at the conference we'll flash it to the badge and show them up on the screen, and we'll pick some winners from the demo scene contest. So I'm pretty excited about that. This is the actual production badge, so we have the first set of badges out. And Voya added a little prototyping area, and he put a accelerometer on there, and so he actually, now you can tip it, and he wrote this program. No, what's really incredible, and I have it playing his Tetris too, he doesn't know any C, he doesn't know any high-level languages. This is written 100% in assembly. So and here's the address, hackaday.io/Belgrade. And it totally works, so come and play Tetris on this, one of the first 3 prototype badges right here.
Very cool.
Thank you.
Mike, please pronounce your last name for me.
Oh, my